Right now, the Milky Way is moving, not just expanding with the rest of the universe. Moving in a specific direction at 600 kilometers per second toward a single point in the sky. And it's not alone. Every galaxy near us is doing the same thing. Hundreds of them, all drifting the same way at over 2 million kilometers an hour. In the 1970s, astronomers first noticed this. They subtracted out every motion they could account for. The Earth's orbit around the Sun, the Sun's orbit around the galaxy, all of it. And after all of that was removed, there was still a leftover drift, a pull coming from one specific direction. When they turned their telescopes to look at what was causing it, they found nothing. Not because nothing was there, because our own galaxy was in the way. The gas and dust of the Milky Way form a thick band across the sky, and whatever was pulling us sat directly behind it. Hidden. If you want to know what's behind that blind spot, subscribe. We go looking. They called it the Great Attractor. For decades, nobody could figure out what it was. The answer turned out to be stranger than anything they'd guessed. Not exotic, just much bigger than anyone thought possible. In the early 1980s, at the Carnegie Observatories in Pasadena, California, an astronomer named Alan Dressler was staring at a spreadsheet of galaxy velocities that refused to make sense. He was part of a team of 7. Sandra Faber, David Burstein, Donald Lynden Bell, Roger Davies, Roberto Turlevich, Gary Wegner. They'd been measuring elliptical galaxies for years, tracking how fast each one moved and in which direction. They called themselves the 7 Samurai, half as a joke, half because the project had taken on a life of its own, and they needed something to call it. The expectation was straightforward. The universe is expanding. Galaxies drift apart from each other. Edwin Hubble worked that out in 1929. The further away a galaxy is, the faster it recedes. Predictable. Their data said otherwise. Galaxy after galaxy showed a velocity that broke the pattern. They weren't just expanding outward. They were being pulled sideways. All of them drifting toward a region in the southern sky, near the constellations Norma and Triangulum Australe. The numbers were large. Peculiar velocities of 400 to 700 kilometers per second. Dressler sat with those numbers for weeks. The pull they were measuring implied something out there with the mass of tens of thousands of galaxies. He originally called it the Very Massive Object. Then he thought about that name for a while and decided it was the dullest thing any astronomer had ever come up with. He renamed it the Great Attractor. But they had a problem, a stupid one. They couldn't see it. The Great Attractor sits directly behind the disk of the Milky Way. All the gas and dust in our galaxy form a band across the sky that blocks the view in that exact direction. Astronomers call this the zone of avoidance. About a fifth of the entire sky is hidden behind it, and the Great Attractor is parked right in the middle. For years, that's where the mystery stayed. A gravitational pull strong enough to drag hundreds of galaxies off course, and no way to see what was causing it. Then X-ray and infrared telescopes changed things. Those wavelengths passed through galactic dust. And in the 1990s, astronomers finally identified a galaxy cluster at the center of the Great Attractor region. The Norma Cluster, about 220 million light-years away. The closest massive galaxy cluster to the Milky Way. For a while, people thought that was the answer. The Norma Cluster is the Great Attractor. Mystery solved. Except the math didn't work. The Norma Cluster was massive, but not massive enough. Its gravity only explained a fraction of the pull. Whatever was causing the rest had to be much larger. It took another 20 years to find out what. For decades, the assumption was that the Great Attractor was a thing, a massive object, sitting in one place, pulling everything toward it. In 2014, a team of 4 scientists proved that picture wrong. Brent Tully at the University of Hawaii, working with Hélène Courtois in Lyon, Yehuda Hoffman in Jerusalem, and Daniel Pomeride in France. They had a catalog of over 8,000 galaxies with measured distances and velocities. The Cosmic Flows 2 database. Most galaxy surveys map positions, where things are. This team did something different. They mapped how things were moving. Every galaxy has a velocity. Part of that comes from the expansion of the universe. Subtract the expansion, and what's left is the peculiar velocity, the part that comes from gravity alone. The direction something is actually being pulled. When they plotted 8,000 of those peculiar velocities in 3 dimensions, the screen filled with streams. Rivers of galaxies, all flowing inward, converging on the same gravitational center. Tully looked at the visualization and saw the pattern immediately. It wasn't hundreds of galaxies being pulled toward a point. It was roughly 100,000, spread across 500 million light-years. The galaxy motions revealed where the mass was hiding, including dark matter that can't be seen directly. The visible galaxies are only part of it. Most of the pull comes from matter nobody can observe. They had found a supercluster, not the old Virgo supercluster from the 1950s. That turned out to be one small neighborhood inside something far larger. They needed a name. Nawa'a Napoleon, a professor of Hawaiian language at Kapiolani Community College, suggested 2 words. Lani, meaning heaven, and Akea, meaning spacious. Lani Akea, immense heaven. 100,000 galaxies spread across 500 million light-years, a total mass of about 100 million billion suns. And at the gravitational center, at the bottom of the valley where every stream converges, the Great Attractor. And that's what changed the whole picture. The Great Attractor isn't an object, not a black hole or some unknown structure. It's a location, the lowest point in a gravitational landscape. Galaxies flow toward it, the same way water runs downhill. Not because there's anything special about the bottom, just because that's where the slope leads. The Milky Way sits on the outskirts, nowhere near the center. Tully joked about it. We live in the local group, which is part of the local sheet next to the local void. We're the far edge of our own supercluster. Zoom out further, and Laniakea is one knot in the cosmic web. Filaments of galaxies stretching across billions of light-years, connecting clusters, with enormous voids in between. But Laniakea isn't the biggest pull in our neighborhood, not even close. And what lies beyond it is what makes the Great Attractor look like a speed bump. In 2005, astronomers re-examined the Great Attractor's mass. The updated number came back at about 1/10 the original estimate from the 7 Samurai. The Norma cluster and its surroundings were real, but nowhere near heavy enough to explain what they were seeing. The rest of the pull was coming from further out. About 650 million light-years away, along the same flow lines, sits the Shapley supercluster. More than 8,000 galaxies. The most massive concentration of galaxies within 1 billion light-years of Earth. The Great Attractor isn't the end of the line. It's a waypoint. Everything in Laniakea flows toward the Great Attractor, and the Great Attractor, together with everything around it, is being pulled toward Shapley. We're being pulled toward something that's being pulled toward something bigger. In 2017, Tully's team found another piece, on the opposite side of the sky from Shapley, a vast empty region they called the Dipole Repeller. A void with so little mass that galaxies near it drift away from it. So we're not only being pulled forward by Shapley, we're being nudged from behind by emptiness. 2 forces working across hundreds of millions of light-years that we had no idea existed until recently. But the ending of this story isn't what anyone expected. Laniakea can't hold together. It's too large. The distances are too vast for gravity to bind it. and the expansion of the universe is accelerating. Dark energy, whatever it is stretching the space between galaxy clusters faster every year. Right now, gravity still wins locally. The Great Attractor can still pull us toward it. That'll hold for a few billion more years. But dark energy doesn't stop. The gaps keep widening. Eventually, the Great Attractor will be so far away, its pull fades to nothing. When that happens, the rivers stop. Laniakea comes apart. Not violently, not dramatically. Galaxies that spent billions of years flowing toward the same center will drift away from each other, slowly, one by one, until there's no trace that they were ever connected. The Great Attractor is losing. It just doesn't know it yet. We spent 40 years trying to figure out what was pulling our galaxy off course. We mapped the motions of thousands of galaxies and found we're inside a current, 100,000 galaxies wide, all moving the same direction. And the answer wasn't some unknown force, it was gravity. Ordinary mass. Galaxies accumulated over billions of years, bending space around them just enough to set everything nearby in motion. Right now, tonight, the Milky Way is drifting at 600 kilometers a second toward a region of space it will never reach. Carried along by a current older than the Earth, one that's already starting to weaken. Nobody will notice when it finally stops. But the galaxies that used to be neighbors will keep drifting further apart. And the valley that once held them all together will slowly flatten out until there's nothing left of it. That's the Great Attractor, not a mystery, a tide going out.